Okay, now we see the titration of mixture of compounds. Here we got a mixture of compounds with acid, base, or oxidizing or reducing agents. Still, we discussed about the problems in which titration. Titration means nothing but the other word for the reaction. The reaction, one of the reaction methods. Okay, just addition method. Okay, two compounds ela add shallow. Titration is one of the methods. We know that. Okay, here the titration, nothing but reaction takes place. Mixture of compounds with and another substance. Okay, so generally normal X, Y are reacted or titrated. Here the mixture of these compounds is reacted with and another substance. Here we are going to discuss the reaction of mixture of compounds. For example, here we are taking the mixture of two compounds. Okay, this total mixture, for example, say it is A. It consists of two mixture. It is now titrated, nothing but reacted with an acid or base or oxidizing agent or reducing agent. So how to calculate this type of problems? Okay, now we see the general example. For example, there is a mixture which contains sodium carbonate and potassium carbonate. So this is the mixture. Now this mixture is reacted with HCl. Here it is acid. So how to estimate the amount of sodium carbonate, how to estimate the potassium amount of potassium carbonate, or how to amount the amount of HCl used. Generally the reaction మన milli equivalents తో ఈక్వలైజ్ చేసి ఫర్దర్ క్యాలిక్యులేషన్ చేసేస్తాం. బట్ ఇఫ్ మిక్చర్ ఆఫ్ కాంపౌండ్స్ ఉన్నప్పుడు ఏంటంటే దిస్ మిక్చర్ ఆఫ్ కాంపౌండ్ totally reacted with this part and giving some parts, some products. So here the important one, ఈ two compounds mixture తో ఇది రియాక్ట్ అవుతుందా కాదా, that is very important one. మనం ఇక్కడ తీసుకున్న ఎగ్జాంపుల్ Na2CO3 HCl తో రియాక్ట్ అవుతుంది. K2CO3 also react with HCl. So now we can write the milli equivalence of this mixture is milli equivalent of Na2CO3 and milli equivalence of K2CO3 is exactly equal to the milli equivalence of HCl. The రెండు milli equivalents add చేస్తే that must be equalized with the milli equivalence of HCl. Just like normal problems లో సింగిల్ కాంపౌండ్స్ మనం ఈక్వలైజ్ చేస్తాం. ఇక్కడ మిక్చర్ ఆఫ్ కాంపౌండ్స్, ఆ మిక్చర్ ఆఫ్ కాంపౌండ్స్లో ఉన్న అన్ని కాంపౌండ్స్ రియాక్షన్లో పార్టిసిపేట్ అవుతాయి, అంటే ఈ పర్టికులర్ కాంపౌండ్తో రియాక్షన్లో ఇన్వాల్వ్ అయితే we use this type of formula, and milli is the addition of the sum of milli equivalence of all components in that mixture. And ఆ మిక్చర్లో ఉన్న అన్ని కాంపోనెంట్స్ కనుక ఆ అదర్ రియాక్టెంట్తో రియాక్ట్ అవుతాయి, వాటన్నిటి మిల్లీ ఈక్వలెన్స్ సమ్ చేస్తే దట్ ఈజ్ ఈక్వల్ టు ద మిల్లీ ఈక్వలెన్స్ ఆఫ్ దట్ పర్టికులర్ అదర్ కాంపౌండ్. అండ్ దెర్ ఈజ్ సమ్ అదర్ పాసిబిలిటీ. ఇక్కడ మిక్చర్లో ఉన్న టూ కాంపౌండ్స్ ఈ థర్డ్ వన్తో రియాక్ట్ అయినాయి, ఒక్కోసారి అన్ని రియాక్ట్ అవ్వకపోవచ్చు. దెన్ వాట్ ఈస్ హౌ టు డూ దట్ క్యాలిక్యులేషన్స్? Here we are taking another example. Here there is a mixture of ferrous sulfate and ferric sulfate. So this is the mixture. Now this is reacted with any oxidizing agent, potassium permanganate Example, potassium permanganate. So we know that potassium permanganate is an best oxidizing agent. It is a best oxidizing agent. So the oxidizing agent means it oxidizes these compounds. When FeSO4 can be oxidized with the potassium permanganate because it is in ferrous state. It can be oxidized to ferric. So it is oxidized with KMnO4. Now see this point, this is ferric sulfate. Ferric sulfate cannot be oxidized by KMnO4 because already it is in ferric form. Fe+3 form లో ఉంది. ఇంకా ఆక్సిడైజ్ అవ్వడానికి పాసిబిలిటీ లేదు దీనికి. అంటే అది రియాక్షన్లో ఇన్వాల్వ్ అవ్వదు. అంటే ఈ మిక్చర్ మొత్తం మనం దీంతో కంబైన్ చేసి రియాక్షన్ చేసినా ఈ పార్ట్ ఆక్సిడేషన్ అవ్వదు, ఓన్లీ ఈ పార్ట్ ఆక్సిడేషన్ అవుతుంది. సో కాబట్టి now we can write the milli equivalents of FeSO4 are exactly equal to the milli equivalents of KMnO4 just by leaving this unreacted compound. Okay, so these are the two possibilities. Mixture lo anni compounds react avvachu, mixture lo konni compound react avvachu, konni compound react avvakavochu. React aina part ni manam calculate chestam, that is equalized with the milli equivalents of that remaining compound. At the KMnO4 example, KMnO4 తీసుకుంటాం. In the place of KMnO4 we can write K2Cr2O7. It is also a good oxidizing agent. Okay, from it also FeSO4 authority, Fe2SO4 taken 3 does not react. So we two choices. Now we do the calculation, some problems based on this concept. Okay. Okay, see the first one. Here 0.5 grams of fuming sulfuric acid. So what is fuming sulfuric acid? Fuming sulfuric acid is known as oleum. It's known as oleum. It's a mixture of SO3 and H2SO4. Okay. This 0.5 grams of fuming sulfuric acid is diluted with some water, and this solution is completely neutralized. 26.7 milliliter of 0.4 m NaOH. Here the question is we need to find the percentage of SO3 in the given solution. But given solution ఏముంది, 0.5 grams of oleum sample. Oleum nothing but SO3 plus H2SO4. దీంట్లో ఈ SO3 percentage మనం ఫైండ్ అవుట్ చేయాలి. ఈ టోటల్ కాంపౌండ్ ఎంత 0.5 గ్రామ్, టోటల్ సొల్యూషన్ ఫామ్లో ఉంది. దీంట్లో ఎంత కాంపౌండ్ ఓలియం ఉందంటే 0.5 గ్రామ్. ఆ 0.5 గ్రామ్లో SO3 percentage we need to find out. Okay. Here important, this SO3 is acidic character, H2SO4 is also acidic character. Now both react with this NaOH. Both react with this NaOH. Okay. But we don't know the weights of SO3 and H2SO4. If you calculate the weight of X, then we are able to calculate the percentage of X in 0.5 gram, percentage of SO3 in 0.5 gram. The SO3 weight, ఈ SO3 weight ఏం తీసుకుందామంటే just we are taking as X, just we are taking as X grams తీసుకుందాం. Just like weight of SO3 is X gram. Weight of SO3 X gram అయితే automatically the weight of H2SO4 is 0.5 minus x gram. Okay, so this is the different weights of these two one. So both are already said the both react with this base, as these are acidic characters, they react with this base. So now we can write the milli equivalent of SO3 plus milli equivalent of H2SO4 are exactly equal to the milli equivalent of NaOH. Okay. Now N1V1. This type of calculation we do like this. Same N1V1 equals N2V2. So here we need to calculate the normality of this total solution. We total solution manaki weight by general normality calculation tone chestam. Like first weight. So what is this weight with x grams? For normality we used to calculate equivalent weight. Okay. Weight x. Its equivalent weight how much? SO3 means what's molecular weight? 32. What is approximately 80. So okay, 80 by 2 by taking its valency, that is equal to 40. Okay, this is the equivalent weight. Okay, this is weight by equivalent weight. Weight is x grams. What is equivalent weight? Equivalent weight means 80 by 2. Here SO3 is its valency treated as 2. 80 by 2, 40. Yes. What is weight? H2SO4 0.5 minus x by weight by equivalent weight. What is equivalent weight? Equivalent weight means molecular weight by its basicity. What is the molecular weight of H2SO4? 98. 98 by 2 means here we get 49. Into 1000 by V milliliters. Weight by equivalent weights. Weight by equivalent weight into 1000 by V. This is for normality and this is for normal value. What is N2? N2 for NU is given in terms of molarity. That is 0.4 molarity. So normality equal molarity into its acidity. NaOH acidity 1. What is value? 26.7 milliliters. Here now we need to calculate the X by simplification. So here by taking LCM, so we will get 1960, and this is 49x plus 42 minus x. We will get cancelled. Here 26.7 into 0.4. Here approximately we will get 68. So by simplification, 49x 0.40.5 that is equal to 20 minus 40x 1000 means comes here 10.68 into 1960. 49x 40x means 9x plus 20, so it will be equal to approximately 3. This is taken as a 2 minus 3. Here we get 9x plus 20 equal to 25. 0.932. So 9x equals x equals so directly we will get this gives approximately 0.103 grams. So this is the x is taken as the weight of SO3. So now you got the weight of SO3 is 0.103 grams. And what is the mixture? 0.5 gram mixture of OEM. SO3 plus H2SO4 mixture lo 0.5 gram lo X and SO3 and 0.103 grams. Here మనం percentage find out చేయమన్నాం కాబట్టి the percentage of SO3 equal to weight of SO3. Weight of SO3 by total weight into 100. So what is the weight of SO3? 0.932. What is the total weight? 0.5 into 100. So here approximately you will get so finally you got 0.103, not 0.932. So after calculation here we get 0.103. And finally approximately we will get 20%. Okay, 20.6%. So this is the composition, nothing but this is the percentage of SO3 in it. And from this we are able to calculate the percentage of H2SO4 also, but here it is asked only the percentage of SO3. Okay. Okay, see the second one. Here 1.8 grams of calcium carbonate and magnesium carbonate were treated with 50 milliliter of 0.8 m HCl solution. Okay, here the calcium carbonate magnesium carbonate mixture is treated with HCl solution. Here we need to calculate the percentage of both CaCO3 MgCO3 in this 1.84 grams of mixture. Okay, here we need to remember that, but we need to know that whether the two compounds react with this given compound or not. Okay, this depends on our knowledge or nothing but book knowledge. So here CaCO3 reacts with HCl, MgCO3 also reacts with HCl. Okay, so now we can write milli-equivalents of CaCO3 and milli-equivalents of MgCO3 were exactly equal to the milli-equivalents of HCl and 2V2. For normality, so weight by equivalent weight. So let weight of CaCO3 just take as x gram. Then what is MgCO3? The weight of MgCO3 will become 1.84 minus x. So from this we start the calculation. Same one V1 equal to V2. So weight by. So what is the, for normality we do the calculation weight by equivalent weight. So what is the weight? X. What is the equivalent weight? Means molecular weight by its basicity. Sorry, it is a salt. We need to write its charge Ca plus 2, CO3 minus 2. As it is a salt, we need to use the for equivalent weight molecular weight by charge. What is molecular weight? What is the charge? By 2 plus its weight 1.84 minus x. What is molecular weight? Here MgCO3 molecular weight so 84 by, as it is the salt, we need to use their charge units. These are the weight by equivalent weight into 1000 by V milliliter into V, that is equal N2 of HCl. This is for HCl. 0.8 m, 0.8. Normality means molarity into its basicity, it is 1. What is the value? It is 50. Okay. So by simplification, x by 50 plus 1.84 minus x by 42. They get cancelled, becomes 8 into 15 into, it becomes 10 power minus 3. So by taking LCM, we are able to calculate this x. So this LCM we will get here we will get approximately 2100. This is 42x minus 50 into 150 . So here 0.8, this is approximately we will get 40. X minus 15 to 1.84. Approximately we get 92 minus 50x. This one. Here 10, 10, 10, this will be cancelled. So finally we will get this is minus 8x plus 92 is approximately 84. 8x equal to here x equal to that's 1 gram. So the weight of so we take the weight of CaCO3 is equal to x. ఇప్పుడు weight of CaCO3 ఎంత మనకి 1 gram. సో ఇందులో 1.84 గ్రామ్ అంటే రిమైనింగ్ 0.84 గ్రామ్స్ ఏంటిది MgCO3. ఓకే, ఇప్పుడు x ఈక్వల్ టు 1 గ్రామ్ వచ్చిందంటే వాట్ ఇస్ మీన్ weight of CaCO3 is 1 gram. Okay, weight of CaCO3 1 gram కాబట్టి the weight of MgCO3 1.84 minus 1, that is 0.84 gram. Oh, so these are the weight of CaCO3 and weight of MgCO3. But in the problem, so it is given that we need to calculate the percentage of CaCO3 and percentage of MgCO3. Here at last finally you got that weight of CaCO3 1 gram, weight of MgCO3 0.84 gram. So దీన్ని మనం పర్సెంటేజ్ లోకి క్యాలిక్యులేట్ చేయాలి. The percentage of CaCO3 means weight of CaCO3 how much? 1 by what is the total weight? 1.84 into 100. So approximately here we get 54.35. And what is the percentage of MgCO3? The total percentage always 100. So finally we will get Okay, these are the percentage of CaCO3, MbCO3. Okay. Okay, see the next problem. It is somewhat similar to the earlier ones. 0.4 grams of a mixture having sodium oxalate and potassium oxalate requires 50 milliliter of m by 60, nothing but 1 by 60 molarity potassium dichromate in acidic medium for complete reaction. So we need to calculate the percentage composition of the mixture. And I am given 0.4 gram mixture lo sodium oxalate ఎంత percentage ఉంది, potassium oxalate ఎంత percentage ఉంది, find out చేయాలి. Okay, so మనకి ఇక్కడ important one, these two reacts with the K2Cr2O7 or not. K2Cr2O7, we know it is a best oxidizing agent. So sodium oxalate reacts with potassium dichromate. Potassium oxalate also react with this potassium dichromate. So now we can write milli equivalent of sodium oxalate plus milli equivalent of potassium oxalate are exactly equal to the milli equivalents of K2Cr2O7. Here take the general formula n by v1 equals n2v2. To calculate the normality, we must know the weight. We don't know the weights. So take the weight of sodium oxalate x. Sodium oxalate x grams తీసుకుందాం. ఆటోమేటిక్గా పొటాషియం ఆక్సలేట్ ఏమవుతుంది, 0.4 మైనస్ ఎక్స్ గ్రామ్స్ అవుతుంది. సో దాన్ని బేస్ చేసుకొని నార్మల్ అంటే వెయిట్ బై ఈక్వలెంట్ వెయిట్ తీసుకోవాలి. వెయిట్ అంటే ఇది ఎక్స్ గ్రామ్. సో ఈక్వలెంట్ వెయిట్ మీన్స్ మాలిక్యులర్ వెయిట్ బై దిస్ ఇది సాల్ట్ కాబట్టి చార్జెస్ తీసుకోవాలి. C2O4 minus 2, 2 sodiums కలిపి plus 2, like a charge 2. So what is the molecular weight of sodium oxalate? Sodium oxalate molecular weight we will get 134 by 2. The 2 indicate the charge plus what is weight, 0.4 minus x weight. So by equivalent weight. Equivalent weight means again molecular weight by basicity. So here it is a salt కాబట్టి in charge. C2O4 minus 2, 2 potassiums కాబట్టి plus 2. Okay. So what is molecular weight? Potassium 39, carbon 12, oxygen 16. By total calculation, so we will get 2 into 1000 by value into V. This V. What is N2? N2 here indicates about potassium dichromate. This is 50 milliliter m by 6. M by 6 means molarity 1 by 60 into what is n factor. Normality direct molarity ఇచ్చింది కాబట్టి normality equal molarity into n factor. So molarity into what is n factor? For Cr2O7 minus 2, n factor is always 6. How it is? Cr2O7 minus 2 is changed to 2Cr plus 3. Here 2 chromiums changed from plus 6 state to plus 3 state. Totally difference is 6 electrons. That is 6. What is the value? It's a 50. It's fine. So here we will get cancelled. And here we can write 67 plus x by equal to 5, so this is here minus 3. So on further simplification we will get the x. Can we do that? here. So by taking LCM, here we get LCM approximately equal to this is 83x plus 67 into 0.4 minus x, that is equal to 5 into 10 power minus 3, and here there is 83x, 67 into 0.4, 67 to 0.4 we will get it's equal to 5 into 10 power minus 3 into 5561. Okay, and here the 83x, okay, 67x. Here we will get 16x plus 26.8. Here 5561 into 5 is approximately 28,000. 27,805. And 16 is equal. Here it can be written 27.805 minus 26.8. Here we will get approximately 1 by 16. And 1 by 16 we will get that is equal to 0.06 gram. Means what is x? Here x is taken as the weight of Ne2C2O4. So the weight of Ne2C2O4 is 0.06 gram. The remaining will be from 0.04 grams. That is equal to potassium oxalate. But it is given that we need to calculate the percentage composition and percentage of both potassium oxalate, sodium oxalate, potassium oxalate, sodium oxalate, రెండు find out చేయాలి. Okay, here you see the percentage of sodium oxalate. What is the weight of sodium oxalate here? 0.06. What is the total weight? 0.4 into 100. Here approximately we will get 15.6%. Then the percentage of K2C2O4. There is only two compounds are there. Percentage in total 100. So by removing that percentage, finally we will get 84.4% for potassium oxalate. So these are the problems based on the combined mixtures reacted with a particular compound, and find out this estimation of that particular compounds in the mixture and their percentage. Okay, just practice in the book. There is some other problems are also given.